Hello, I'm Jennifer Rode. I'm presenting work I did with Louise, Barkhuus, and Andri, Ioannou, called Exploring Gender, Computational Making, and E-Textiles using the BBC microbit. There are 5 million BBC microbits that have been sold. They're used by over 25 million teachers, and in the United Kingdom, they were rolled out to all Year 7 students. Given an average price of £15 per kit, that's over 75 million pounds, about $95 million. We know from the incredible shrinking pipeline and this year's Computer Research Association that there's a gender gap of girls and women in STEM, and the microbit was meant to close this gap. It says on microbit.org that there was, quote, a particular focus on girls. And Rogers et al. Talked about how the microbit was universally accessible and gender neutral. Yet, despite the importance of e-textiles, we've found that no prior work exists on the BBC microbit, gender, and e-textiles. Rode et al. Have argued that moving from computational thinking to computational making encouraged gender equity and was better suited to STEAM. Prior work by myself, Weibert, and others emphasized that e-textiles are unique in their ability to appeal to a more gender-diverse demographic population. We've seen some studies of gender equity with the BBC microbit, but their findings regarding gender are limited. And so we would argue there's a significant gap examining e-textiles gender and the microbit, which we've attempted to fill with our study of 24 children. This was a qualitative study, 11 girls, 13 boys, who participated in a 4-hour summer school workshop at a makerspace in Cyprus. We asked the children to create an e-textile object using the microbit version 1 to control external LEDs, so not the 5x5 grid on screen. You can see the microprocessor here, but rather you attach the LEDs, the positive to the 0, the 1, and the 2 pin using an alligator clip, and completed the circuit by attaching an alligator clip to the ground. We analyzed the data using thematic analysis with the 5 computational making themes: aesthetics, creativity, construction, visualizing multiple representations, and understanding materials. We're going to present 2 of these now. The rest are in the paper. I'd encourage you to read it. One innovation based on our prior work was to require the children to draw circuit diagrams. Now, they viewed this as an unpleasant chore, but it helped us to identify misconceptions and discuss circuit layout strategies to avoid problems. And then children used these circuit diagrams as a reference tool during construction. Thus, we'd argue circuit diagrams are a beneficial scaffolding tool here. You can see an example of a child drawing a tiger, and that it didn't always work out. The tiger's body was big enough for the microbit, but then in the final project, that didn't quite work out. But I also want to draw your attention to the way that the alligator clips attach to the microbit. And I want you to note that all of those alligator clips should be parallel. Anytime they're at an angle, especially if they're at a 90-degree angle, you run the risk of shorting the circuit, and that can cause significant technical problems, which I'll refer to on the next slide. In the case of this particular example, the ground pin is a bit bigger, so turning it 90 degrees didn't short it out, but that child got very lucky. Students were struggling with tools, including needles and thread and cutting with scissors. The conductive thread itself frayed, resulting in fuzzy balls that were snipped off but tended to reattach to the felt. And this shorted circuits, which made them very difficult to debug. We would argue on a whole that there's a pressing need for more appropriate e-textile tools and resources to be developed. We need fray-resistant thread. We need kits where the eyes and the hardware are compatible with the needles. And we need felt that doesn't melt. We also need sewable alligator. We also know that sewable alligator clips for connecting the BBC microbit are an untenable solution. We need something that allows for stable electrical connections and easy removal. And we've prototyped a new sewable edge connector to address this. That's the thing in red. And you could imagine that you would sew onto the leftmost and rightmost hole. And then there are only 2 of these, but you could imagine 5 attachment points where it would sort of slip on with fingers over the base. And then you would sew onto the little holes so that that would stay attached to your fabric, and you could pull the microbit in and out, and it would create a stable connection. Our future work will need to evaluate this. Now, it's taken us 5 years to publish these findings. We published it in AltCHI because it was considered so controversial. Our reviewers were concerned that assuming girls are interested in e-textiles is gender essentialist. But we would argue that it's condescending to assume children, especially girls, can't decide for themselves if they're interested in e-textiles. While the influence of the patriarchy is significant, it's crucial to recognize that individuals have the agency to make their own choices. People of all genders continue to show interest in fashion, textiles, crafts, and the arts, and makers need a full range of gendered applications like e-textiles to be supported in STEAM education. Based on this study and my prior work, I would argue the LilyPad is a vastly more usable e-textile platform. But there is a £75 million investment in the BBC microbit that must be leveraged. So in this paper, we have shown ways that the BBC microbit must be improved to be a viable e-textile platform for children of all genders. Thank you so much for your time, and I'm happy to answer questions via email or if you are at the conference in person. Good day.